Hello, sorry I can't be there once again. We've been fighting the flu in my house, so I will be home today, but you guys get to still learn some fun algebra stuff. You should have your day 7 notes out, and yesterday we talked about how to graph one of these inequalities on the coordinate plane. Now we're going to be graphing two on the same one. And what's going to happen is where the shading overlaps, that's where your solution is going to be. Now I'm going to show you one way to do it. I don't prefer this way, and then I'll show you another way that I think is a little bit easier to see. So let's look at number 1. We've got y is greater than or equal to 2x plus 3. So we're going to graph it just like we did yesterday. Your y-intercept is 3. Your slope is 2. So you're going to go up 2 and right 1. And you can do that multiple times if you'd like, up to right 1, etc. Down to left 1. Since we're going to be graphing two lines, I'm going to kind of make more points than we did yesterday, just so that we can see where these two lines intersect. So I just went up 2 over 1 and down to left 1 a bunch. Because it's greater than or equal to, we know that that's going to be a solid line, so we can connect the points like so. And then because it's greater than or equal to, we know that we shade above. Now I'm not going to shade all crazy. What I'm going to do is I'm just going to kind of shade lightly. You can probably do that more easily with a pencil, but I'm just kind of shading above because it's greater than. Now with the other line, we've got y is less than or equal to negative 3x plus negative 3 halves x plus 10. So we know the y-intercept is 10. Negative 3 halves means we go down 3 and right 2. All right, we found the spot where they intersect. You can go down 3 and right 2 some more if you want, but we're good now that we know where they cross. It's less than or equal to, which means that it will be a solid line. All right, and then because it's less than or equal to, that means we shade below the line. So below this green line would be everything here, 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 and here. The goal after this is to figure out where the shading is overlapping. So where my blue and my green shading is overlapping. And you can kind of tell where they overlap. And they overlap everywhere in this section. All right. The blue and the green shading overlap all in here on like the left section of this X. And that's going to be your solution. Now I'm going to show you another way because I don't like doing shade, shade, and then shade darker because I feel like it gets really busy and it's really hard to see where the shading overlaps, especially when you have more than just two lines, which we will do at some point. So let's try, doing it a different way. So let's look at number 2. If you look at this one, you've got y is greater than negative 3/4 x minus 3. So the y-intercept is negative 3. The slope is negative 3/4. So you can go, down 3 and right 1, 2, 3, 4. And you can do that several times if you want. Down 3 and right 1, 2, 3, 4. You can also go up 3 and left 4 if you'd like. And because it's greater than, we know it's going to be a dashed line, just like yesterday we talked about that. So I connect the points with a dashed line. And then it's greater than, which means that I would shade above. Instead of shading above, what I'm going to do is I'm just going to draw some arrows to indicate that I would be shading above this line. All right, so that way it doesn't get so messy with all the shading going on. So there's that line. Then we do the next line. The next line has a y-intercept of 9. Slope is negative 3/4. So again, we're going down 3 and right 4. And you can do that a couple times if you want. But you'll notice, they have the same slope, so they're going to be parallel lines. This is less than, so we know it's going to be a dashed line. And less than means we shade below. Instead of shading all crazy below, I'm just going to draw arrows indicating that I would shade below the red line. And now we can kind of figure out where our solution is. So all the shading has to be above the blue and below the red. So my solution is going to be everywhere in between. Everything in between the red and the blue. Above the blue and below the red. And that's going to be our solution area. So any points in these shaded areas work for both inequalities. All right. Over here in number 1, anything in the shaded area will work in both inequalities. When you plug them in, it's a solution for both. All right. Let's look at number 3. So I'm going to continue with the arrows. In the past, most of my students like the arrows because the shading gets a little busy. If you prefer shade, shade, and then shade darker, like number 1, you can totally continue to do that. All right, so for number 3, you've got y is greater than or equal to -6. Anytime you've got, y by itself, that's going to be a horizontal line. You find -6 on the y-axis. It's greater than or equal to, which means that it is a solid line. And it's greater than, so that means you're going to shade above. Now you can shade lightly above, or you can just draw little arrows. That's what I'm going to do. And then you have the other line. Now the other line, we've got to actually get y by itself. So I'm going to add 2x to both sides. We have -6y is less than 36 plus 2x. We're going to divide by -6 on all sides. We're going to reduce. You got 36 divided by -6 is -6. 2 divided by -6 is -1/3. And because I divided both sides by negative, it's going to flip the inequality. So we've got a y-intercept here at -6. My slope is -1/3, which means I go down 1 and right 3. You can also go up 1 and left 3. It's greater than, which means that it's going to be a dashed line, connecting those points together. And it's greater than, which means I shade above. So where I'm going to shade has to be above both the red and the blue. All right, so above both the red and the blue is going to be this huge area all in here. All right, this whole area is above the red and above the blue. All right, this area down here wouldn't be part of it because it's not above the blue. This in here would not be part of it because it's not above the red. It's got to be above both red and blue. And so this whole area would be your solution area. So if you plug in like 0, 0 into both inequalities, it will work. Let's see. Let's try another one. With number 4, x is less than or equal to 4. Remember, if it's x equals, that's a vertical line. So you got to find 4 on the x-axis. Since it's less than or equal to, that will be a solid vertical line. And less than or equal to, normally we shade above, but with the vertical line, less than would be to the left. Remember, less than is to the left. So I would be shading somewhere to the left of this line. Over here, I need to solve for y first. So I got to distribute the 2. I have y minus 6 is less than 2x minus 8. And then you add the 6 to both sides. So you end up with y is less than 2x minus 2. So you're going to end up with a y-intercept of -2. Your slope is 2, so you go up 2 over 1. And I'm just going to keep going until I hit the other line. Up 2 over 1, up 2 over 1. It's less than, which means it is a dashed line. So you connect it with a dashed line. And then less than means you shade below. So it's got to be below this red line and to the left of the blue line. So the area where that's going to meet both requirements is everything in here. That's below the red and to the left of the blue line. So anything in this shaded area is part of the solution set. All right, hopefully this is making sense to you. All right, what I'd like you to do is I'd like you to try number 6. All right, so try this out, pause the video, give it a go, and then press play and see if you got the right answer. Go. Okay, so what you should have done is x is greater than -4. You should have made a vertical line, a dashed vertical line, through -4. It's greater than, so we know we're shading to the right, greater than's to the right. Y is less than or equal to 6. You would have had a horizontal line going through 6. It would be a solid horizontal line. And since it's less than or equal to, that would be below. So it's got to be below the red line and to the right of the blue line. And that area where you're going to shade is everything in here. All right, it's below the red and to the right of the blue. So anything in this shaded area is going to be part of your solution set. And hopefully that's what you got. All right, let's look at number 7. All right, with number 7 it says, in number 6 are the following point solutions. So we kind of talked about this yesterday, and we talked about if it lands in the shaded area, it's a solution. If it lands on a solid line, it's a solution. But if it lands on a dashed line, then it is not a solution. All right, so let's start with I'm going to change the order a little bit. Let's say you got 6, -4. So we'll start with this one first. If you go to where 6, -4 is on the graph, it lands right here. It's in the middle of all this shading, so that is going to definitely be a solution. All right, if you look at 0, 6, all right, 0, 6 lands right here. It's kind of on the edge, but it's on a solid line, so that's part of the solution. So that's a yes. All right, -4, 0 lands here. Well, -4, 0 is on a dashed line, which means that it is not part of the solution. And then -4, 6 is the hardest one. -4, 6 is right here. It's on the corner. It's on both a solid and a dashed line. However, if you have a problem like this, if it lands on any type of dashed line, even if it's on a solid line, the answer is going to be no. So if these were both solid lines, then that would be a yes. But because of that dashed line, the answer is no. All right, so it gets a little tricky with that. What else do we have? And then we did this yesterday. You know, is it a solution? It's got to work for both in order for it to be a yes. So we did this yesterday with only one. Now we have 2. What you're going to do is you're going to plug it in and see if it works for both. So like, let's look at the second one here. You've got x is 16 and y is 2. Plug it into here. So you've got 1/4 times 16 minus 2. And we're going to see if that's less than or equal to 2. So you have 1/4 of 16 is 4 minus 2. 4 minus 2 is 2. 2 is definitely less than or equal to 2. So it works for the first one. Then we got to try the second one. The second one, there's only a y. We plug in 2 greater than or equal to 2. Well, 2 is definitely greater than or equal to itself. It's actually equal to itself. Since it works for both, it's yes. All right, I don't want to see yes, yes. Just tell me overall what the answer is. It's either yes or it's no. All right, same idea like over here. If you were to take this and plug it in, you have 2 times 8 minus 5 times 1, and we're going to see if it's greater than or equal to 10. 2 times 8 is 16. 16 minus 5 is 11. 11 greater than or equal to 10? Yes, it is. So it works for that one. We need to see if it works for the second one. -3 times 8 plus 1, y, is greater than -23. If you plug that in, you're going to get -24 plus 1 is greater than -23. -24 plus 1 is -23. -23 greater than -23? Nope. It doesn't work for that one. So while it works for one but not the other, your answer is going to be no. All right, so it's either it works for both and it's a yes, or it doesn't work for both and it's a no. All right, so I think that's the main idea. I mean, I hope that this makes sense. You're just kind of figuring out, it's like problems from yesterday and figuring out where everything intersects and then shading nice and dark there. All right, so I hope this is okay. If you do have any questions, you can certainly email me and I'll try and get back to you. The homework is what you should be working on next. So the next worksheet in the packet is what will be due on Friday. So go ahead and work on that and have a good day. Thanks.